morning, class. Before we start, kindly open your camera for our attendance in today's discussion. We all know that there are a lot of occurring curves in the world. Before we begin this discussion, let's try to name some of the given pictures. Can you guys tell me which shape of curve this is? Yes, Carla.
Sir, that's a circle.
Excellent. Now, can you tell me the shape of a football? Is this a circle? Yes, Carla again.
No, sir, that's an example of an ellipse. It is almost like a circle, but it is longer on the side.
Wow. Most of my students are intelligent. I'm impressed. Let's see if you can guess the next one. Yes, Irish.
Sir, I think that's the curved part of banana is called parabola.
Lastly, can you guys identify the shape of this image? Yes, Joel.
That is an example of hyperbola, sir.
All the things that we see has one thing in common. They are the four types of conic sections. What do we mean by conic sections? Conic sections are any curve produced by the intersection of the plane and the right circular cone. The shape of the curve depends on the angle of the plane relative to the cone. Do you guys know that you can form the four types of cone sections by cutting a cone, but different angles? Is there anyone who can tell me about how these curves form? Yes, Nicholas.
Sir, when the plane is perpendicular to the axis of the cone, the intersection will produce a circle.
How about you, Nathan?
Oh, sir, when the plane is slightly tilted, it will form an ellipse.
Yes, Jamir.
Sir, when the plane is parallel to the side of the cone, it produces a parabola.
And lastly, yes, Diane.
Most importantly, when the plane cuts both extensions of the cone, it yields a hyperbola.
Okay. Most of the incoming senior high school students and current are confused and anxious about their mathematics subjects. Anyways, you may now leave our meeting. Good luck.
Bye,
Bye,
sir.
sir.
Bye,
Bye,
sir.
sir.
Thank you.
So, how are you, Carla and Luis?
I'm okay. It's just confusing for me.
What can we do to help the both of you understand the lesson more? And of course, those incoming senior high school students less anxious.
What if we create and send them a video discussion?
That's a great idea, and that would be fun.
You guys still don't understand the circle conic section, so I'll explain it for you. A circle is all the points in the same plane that lie at an equal distance from a center point. The circle is only composed of the points on the border. So there are many parts in the circle. So one is the radius. It is the distance from the center of the circle to its outer rim. So next is the chord. It is a line segment whose endpoints are on a circle. Next is the diameter. It is a chord that passes through the center of the circle. The length of a diameter is 2 times the length of a radius. Next is the secant. It is a line that intersects a circle in 2 points. And there is also the tangent. It is also a line that intersects a circle in exactly 1 point only. So next is point of tangency. It is the point where a tangent line touches the circle. So for example, let's take a circle. Then the set of points are on the radius of the circle. Then to know if it is a circle, the point must be equidistant from the center. So in simple terms, if you were to connect a point from the radius to the fixed point, which is the center, it would be the same distance no matter which point. So to get the exact distance, you can use a graph and you can draw a circle on it. Then you get the set of points and get the distance of it from the center using the distance formula. If you get the same distance on all of the points, then this means it is a circle. Circles are used in real life situations as well. It can be found on wheels on cars, bikes, and other forms of transportation. The shape of a circle helps create a smooth movement for a car or a bike to move from place to place. So next is a donut. It is the perfect example of a circle. The shape is a prime factorization of the delicacy. It allows a baker to induce heat distribution to create an evenly baked delicious donut. So let's give an example of an equation of a circle. So an example is here is x squared plus y squared minus 25 equals to 0. That is in general form. So let's try to convert that into standard form. And it's very simple. First transpose the negative 25, then just divide the value of x by 2, then square it, then add it to the both sides. But in this example though, we don't have an x, meaning it is 0. So our equation now is x squared plus y squared equals 25. So let's take negative 5, 0 as an example. So let's take the points of both sides, which is negative 5, 0 and 5, 0. First, we need to find the center. So we use the midpoint from formula. That is x sub 2 plus x sub 1 divided by 2. And y sub 2 plus y sub 1 divided by 2. After we get that, we get 0, 0 as the center of our equation. Then using the distance formula, the distance between points 0, 0 and negative 5, 0, that is the same for 0, 0 and 5, 0. So if you get the distance of them, it is 5. Both of them is 5. And if you get any other point from the circle, you will always get 5 as an answer. And that's how you get that's how you know that it is actually a circle. So I hope you understand my discussion and good luck.
After we learned the circle of the conic section, now let's proceed to the ellipse. What is an ellipse? An ellipse is all points found by keeping the sum of the distances from 2 points constant. The midpoint of the segments connecting the foci is the center of the ellipse. An ellipse can be formed by slicing a right circular cone with a plane traveling at an angle to the base of the cone. An ellipse may also be defined in terms of one focal point and the line outside the ellipse called the directrix. For all points of the ellipse, the ratio between the distance to the focus and the distance to the directrix is a constant. Ellipse is contributed to the real world because of its oval shape. For example, the shape of a lemon is a circular structure with 2 pointy ends. Another example is an Earth's orbit. An Earth's orbit around the Sun is an example of an ellipse. Even your eye is also an example of ellipse. It is a horizontal ellipse. The eyeball can be considered the center, and the surrounding shape forms an ellipse. The minor axis is vertical, and the major axis is horizontal across the eye. The two ends of the eye can be considered as vertex.
What is a parabola? A parabola is a plane curve generated by a point moving so that its distance from a fixed point is equal to its distance from a fixed line, the intersection of a right circular cone with a plane parallel to an element of the cone. In simple terms, a parabola is a curve where any point is at an equal distance from a fixed point called the focus and a fixed straight line called the directrix. What are the general forms of a parabola? There are two general forms of a parabola. The first general form is ax squared plus dx plus ey plus f equals 0. If x is quadratic, the parabola opens up or down. The second general form is by squared plus dx plus ey plus f equals 0. If y is quadratic, the parabola opens to the left or to the right. There are a lot of parabolas around us every day. One example is, imagine you are playing a ball and you throw it in the air with your best friend. You form a parabola without knowing. Another is after rainfall. You will see a beautiful rainbow above the sky. If you look at its shape, it is upside down, wide letter U. Lastly, your headphones. There's a U shape in it for you to wear it in your head. There are more examples of a parabola in real life. One is the Golden Gate Bridge in San Francisco in California, is famous with parabolic spans on both sides. The second are lighthouses. In lighthouses, parabolic bulbs are provided to have a good focus of beam to be seen from a distance by mariners.
The hyperbola can be defined as the difference of distances between a set of points which are present in a plane to two fixed points is a positive constant. It is a two-branch open curve. It is formed when a plane intersects a double right circular cone at an angle such that both halves of the cone are intersected. This intersection of the plane and cone produces two separate unbounded curves that are mirror image of each other. The real-life application of hyperbola is baseball. Its red design is shaped like an hourglass. The Kobe Port Tower has hourglass shape. That means it has two hyperbolas. In nuclear cooling towers, the hyperbolic shape is used due to its ability to withstand the high winds. Power plants looks like an hourglass shape too. There is also a design of vase where it is shaped like a hyperbola. Another example is a lamp. When you turn on its light, if the lamp is open from the top and the light at the bottom comes out, it will form hyperbola. Radio waves can be used in navigations. If the middle of every circle carries out a radio signal, then the signals will interact and form hyperbolas. Lastly, the curves of an acoustic guitar on its sides. The curves of the guitar also represents the curves of a hyperbola. That would be all. Thank you.